A uniform ladder of length 8 meters rests with its upper end against a smooth vertical wall and its lower end on a rough horizontal floor. The coefficient of friction between the ladder and the floor is 3/4 and the angle between the ladder and the floor is 45 degrees. A builder whose weight is twice that of the ladder slowly climbs up the ladder. Find how far up the ladder he will climb before it begins to slip. Now let me go over the question again to analyze and see how to solve. So the problem here is to calculate the distance the builder will climb on the ladder before it starts to slip. Slip here means before the ladder slides or falls. A uniform ladder of length 8 meters. So it means the length of the ladder is 8 meters. Rests with its upper end against a smooth vertical wall. So it means there is a vertical wall and the wall is smooth, means that there is no friction on the wall. The ladder rests with its upper end against the smooth vertical wall. That's the ladder is resting on the wall and its lower end on the rough horizontal floor, means that one of the end, that is the other end of the ladder, is resting on the floor. The coefficient of friction between the ladder and the floor is 3/4. Now you know the coefficient of friction is always symbolize mu, that's they said is 3/4, and the angle between the ladder and the floor is 45 degrees. So this is the angle between the ladder and the floor, that is 45 degrees. A builder whose weight is twice that of the ladder slowly climbs up the ladder. Now let's say this is the builder on the ladder, and you know they have said the weight of the builder is equals to 2 times the weight of the ladder. Let's just take WB to be the weight of the builder and WL to be the weight of the ladder. You know the floor and the vertical wall makes an angle 90. Now we are supposed to find how far up the ladder he will climb before it begins to slip. That's we want to find the distance that this builder is going to climb on this ladder just before the ladder start to slide down, slide from here, or slips out. You know, before the ladder start to slips out or slides or fall, the system must be in equilibrium. For a system to be in equilibrium, 2 conditions need to be fulfilled. The first one is the resultant force must be equals to 0. The second condition is anti-clockwise moment should be equals to clockwise moment. You know, the first thing to do before applying these conditions is to indicate the forces acting on this diagram at equilibrium. There is the weight of this man that is acting downward, that is WB. There is also the weight of the ladder, that is WL, acting downward. You know, when 2 surfaces are touching, there is always a normal reaction force acting perpendicular to the point of contact. So here there is a normal reaction, let's call it N1, and here you see the ladder is touching the ground. There is also a normal reaction acting perpendicular to the point of contact, that is, let's say N2. And you know that from the question they say the coefficient of friction between the ladder and the floor is 3/4. So it means if there is a coefficient of friction between the ladder and the floor, it means that there is friction acting here, because the formula of frictional force is the coefficient of friction times the normal reaction, and the normal reaction at this point is N2. So it means that here is N2, and if the ladder is standing on the ground like this, means the frictional force will be against the ladder from slipping to that direction. So it means the frictional force will be acting to this direction. That's here I have the frictional force. The question is, we want to know the distance that this builder has achieved by climbing this ladder from here to this point, and maintaining the system in equilibrium. So let's say the distance from that point, that is this point to this point, is, let's say, s. We don't know, and you first of all know that the distance of the ladder as mentioned in the question is 8 meters. From here to the base here, the ladder is 8 meters. I know the weight of the ladder acts at the center. If the weight acts at the center, it means from the center of the ladder to this point will be half of 8, which is 4 meters. You know, the system is in equilibrium, and the first condition is that the resultant force must be equals to 0. The resultant force here is in 2 dimensions, that is the vertical dimension and the horizontal dimension. That's the resultant force in the direction of the y-axis and in the direction of the x-axis. Now let's look at the resultant force in the horizontal direction. Let's take the positive x-axis to be the positive direction. So the forces acting in the horizontal direction here are N2 and the frictional force. So you see, it's in the horizontal direction. This is horizontal direction. And to get the resultant of these two forces, I'm going to have N1 minus the frictional force, which is equals to 0. Since the resultant force at equilibrium must be equal to 0, N1 will be equals to the frictional force. Earlier, I was saying that the formula of the frictional force is mu times N2. So it means that N1 is equals to the coefficient of friction times N2, and you know mu from the equation is 3/4. That means here N1 is 3/4 of N2. Now, what about the forces in the vertical direction? That is in the y-axis direction. Let's take the positive y-axis to be the positive direction. These forces acting in the vertical direction are the weight of the builder, the weight of the ladder, and the normal force N2. I need to get the resultant of these forces. Since I've taken the positive y-axis to be the positive direction, it means I'm going to have N2 to be the leading force. That is N2 minus weight of the builder plus the weight of the ladder. All this equals to 0. That means N2 is equals to the weight of the builder plus the weight of the ladder. Since all this bracket goes to the other side of the equal sign, it becomes positive. Now, it is stated in the equation that the weight of the builder is 2 times the weight of the ladder. So it means here I have to replace the weight of the builder by 2WL. That is, I'll have 2WL plus WL, and that one is going to give me 3WL. That means N2 is 3WL. That's 3 times the weight of the ladder. You know, my target in this question is to calculate the value of S. That's the distance of the builder, but there is no S in any of these two equations that I've just obtained. So I need to bring in an equation that have S, so that I should be able to solve, and then I get the value of S. So in this case, I need to apply the second condition for equilibrium, that is anti-clockwise moment is equals to clockwise moment. You know, the anti-clockwise moment means moving from the right to the left, and the clockwise moment means moving from the left to the right. To apply the idea of anti-clockwise and clockwise in this system, I need to first of all choose my turning point. I can choose the turning point anywhere I want. I can choose the turning point here or here, but I will decide to choose here. I'm choosing here because I'm having two forces here. So anytime you choose a turning point where there are forces, the moment of those forces become 0, and then my work of doing calculation have been reduced. So it means that the moment of of the force N2 and the frictional force is already 0, since moment is force times the perpendicular distance from the turning point. And if you take N2 times this distance from here is 0, and F times the distance from here is 0, since all of them are at this point, so their moment is 0. So it means the forces acting in the anti-clockwise direction, which are not at the turning point, is WB and WL. I need to calculate the perpendicular distance of the force WB from the turning point. Now, if you look carefully, the perpendicular distance is from here to here, not along the ladder. Perpendicular means that at 90 degrees to the turning point. So you see, from here is 90 degrees to the turning point. And to get this distance, I need to apply the trigonometric ratio. Let's say this distance is x. You will see that cos 45 degrees is equals to adjacent, which is x, all over the hypotenuse, which is s. From here to here is s, x over s. It means that x is equals to s cos 45 degrees. It means that the moment of WB, that's the weight of the builder, is the force or the weight of the builder times x, that is WB s cos 45 degrees. Now let me calculate the moment of WL from the turning point. That is WL times the perpendicular distance from WL to the turning point. That is this distance here up to this point. Let's say the distance is x, as I've done before. You will see that cos 45 degrees will be equals to x all over 4. That is adjacent over hypotenuse. That's x over 4, since the hypotenuse here is 4. And it means in this case x will be 4 cos 45 degrees. So it means the moment of WL will be WL times 4 cos 45 degrees. So I've calculated the anti-clockwise moment, so I need to calculate the clockwise moment. The clockwise moment is in the opposite direction. N1 is the only force acting in the clockwise direction. I need to calculate perpendicular distance from N1 to the turning point. This distance, this angle is 45, so it means that this angle here should also be 45 degrees, since they are alternate angles. Now, to get this side, I need to apply the trig ratio again. I know that from this point to this point, the distance is 8 meters. That's the length of the ladder, is 8 meters. So that is the hypotenuse of this right angle triangle. You see, from this triangle, sine 45 degrees will be equals to opposite. Let's say the opposite here is x, will be x all over 8 meters. The hypotenuse is the length of the ladder. So it means that this side, which is x, will be equals to 8 times sine 45 when I do cross multiplication. And then it means that the moment of N1 from this turning point will be N1 times the perpendicular distance, which is 8 sine 45. That is N1 times 8 sine 45 degrees. Now I need to simplify this to calculate the value of s. That's WB times s times cos 45, which is root 2 on 2, plus WL times 4 times root 2 on 2, that's cos 45. That's equals to N1, which I obtained earlier as 3/4 N2. So here I'll put 3/4 N2 times 8 times root 2 over 2, since sine 45 is root 2 on 2. Root 2 here can cancel 4 here 2 times, and you see 4 here 1, 4 here 2 times, and again 2 here 1, 2 goes into 2 1 time. From the equation, WB is 2WL, so I need to replace WB by WL. That is 2WL times S times root 2 over 2 plus 2 times root 2 is 2 root 2 times WL, which is equals to 3 times root 2 is 3 root 2 times N2. So that is 3 root 2 times N2. You see, from here 2 can cancel 2, and then I'll have WL times S times root 2 plus 2 plus 2 root 2 WL, which is equals to 3 root 2 times N2. Earlier I calculated N2 to be 3WL, so it means that this is times 3WL. You see, I can still arrange this as S times root 2 WL plus 2 root 2 WL, that's equals to 3 times 3 is 9 root 2 WL. Root 2 WL is common, means I can divide each term by root 2 WL as root 2 WL all over root 2 WL. Now this cancel out, this cancel, and then I'll have S plus 2 is equals to 9. That means S is equals to 9 minus 2. That means S is equals to, that is 7 meters. So the man have to climb 7 meters on the ladder before it starts to slips or slides down.